My friend Clara is a professional saleswoman, and she talked to Santa yesterday. Santa wants to buy a box of gifts, but of course, his box has a weight limit because he need to fly over the city with his fancy car. Clara has three types of items: gloves, headphones, and tennis rackets. Each of these items have different prices and also different weights. She wants to find a way that makes her profit maximum. This is called Unbounded Knapsack problem. So first, let's analyze the problem and then try to find an optimal solution.
The first point that we have to keep in our mind is that we have infinitely many items in this problem, which is the difference between 0-1 knapsack and unbounded knapsack. First, let's decide if we want to include gloves or not. If it's decided to include it, then we will have a subproblem with a new weight limit as 6. And if we decided not to include, then we can move to the headphones. For the case in the left, we should think about gloves as if we started the problem all over again with a box with limit 6. Ultimately, this will be a messy tree that will create huge time complexity, 2 to the power n. The thing we can do to reduce time complexity is obvious even if you have a quick look at these samples. We can see that the subclass W equals 6 appears more than once. That is the very part memoization comes in, which is the heart of dynamic programming.
Here's the code and here's the table. I will try to give the logic behind this solution by filling rows, but first let's understand the structure quickly. When we look at the code, we can see a nested loop. Outer loop stands for vertical movement, so to speak. I mean, we are changing the item. And the inner loop corresponds horizontal ones, so we are traveling inside the current array. And also we have some conditional statements. I'll go step by step to grasp what this code block is doing and most importantly why it's working. Note that as before we have two possibilities, adding the item into the box or not. It's a decision of choosing the maximum value between take and no take. Also notice we are keeping dp array in our memory, and at the very beginning of the algorithm, dp is set of all zeros. It's the implementation of the algorithm. For the first example, we have basically two parts. The first part is directly related to the current value, and the second part is the summation part. We need to look for the value of the item itself, which is 9 in this case, and also we will look at 2 steps back and then add these values before making comparisons, and then we will get final results. Don't forget, write these final results into your DP array. And voila, this is the final result that you can find computing manually or using this code block. Of course, when you have so many items, it's impossible to compute it by your hand. So this is our output, and that means Clara should put 1 pair of gloves and 2 headphones into the Santa's box if she wants to get maximum profit. Sorry, not sorry, Santa.